Hi, welcome to our channel Good News. In the evolution of chip technology, China has not been able to grasp several core key technologies, and Western nations have long held these core key technologies back on a technological level. As a result, it appears doubtful that China wishes to advance further in this field, and advancement is a very challenging process. Therefore, the US leaving the limitation order in the semiconductor sector has made it harder for China to build its chip industry. It is challenging for the present chip manufacturing technology to keep up with China's rapid expansion, which has led to a famine in the semiconductor business. Despite claims to the contrary, it will take a long time for China to overcome some of the hurdles in this area. The existing chips are all in use because numerous individuals during the development process considered other solutions. Nanomaterials, however, they still require further assistance to achieve their technical accomplishment. It is challenging for China to make such a significant advancement so quickly. Can China alter a substance? What sort of materials ought China to switch out for nanometers? What sort of materials ought China to employ to substitute nanometers, then? Naturally, the outcome can only be determined following the experiment. There has undoubtedly also been a conclusion reached in China's experiment. Graphene is a substance that was found in China and is used in long-term exploration. China can employ graphene to create chips because of the particular geometric structure it shares with nanotubes. Additionally, experimental evidence suggests that graphene's electron transport speed is quicker than that of silicon-based materials now in use. This implies that the performance of the device will be greater if graphene is really employed to create chips. China's semiconductor development is fully supported by such an outcome. The available evidence shows that silicon transistors perform 5 times worse in the experimental setting than transistors manufactured of nanocarbons. Even 50 times better than existing technology, the overall performance. Because of these technologies, the development of graphene chips will be more promising for our nation than it is right now. Since this is a completely new subject, no other country is working in it. If China develops well and technology remains at a standstill, the door to the Chinese semiconductor industry will likely open. What is a chip made of carbon? Why choose for chips made of carbon? According to the definition, chips with the core made of carbon nanotubes, graphene, and other materials are referred to as carbon-based chips. Carbon-based chips potentially offer greater transmission and 1,000 times better electron migration capability than silicon-based devices. Speed, reduced costs, and less energy use. Studies have demonstrated that carbon-based circuits produced using the same technology currently perform significantly better than silicon-based devices. As a result, the present development tendency is that carbon-based chips will continue to rely on the current chip manufacturing process and not be split from the current chip industry. A few test items have currently demonstrated that carbon-based chips are truly superior. Transistors are the fundamental building block of current chips, hence in order to create carbon-based circuits, carbon materials must first be used to create transistors. Chinese scientists started investigating the process of creating integrated circuits with carbon nanotube materials in 2000, and 7 years later, in 2007, they established a successful process for creating carbon nanotube transistors. Carbon transistors are tiny cylinders of carbon atoms that are 100 times smaller than existing silicon transistors, meaning that carbon transistors may be made even smaller by employing carbon nanotubes as the channel conducting material. Combining the aforementioned benefits, scientists have predicted that carbon-based circuits manufactured using a 28 nanometers technology will function on par with silicon-based chips manufactured using a 7 nanometers method. Carbon-based circuits outperform silicon-based chips in terms of power consumption and energy efficiency ratio in lab settings by a factor of 5 and 50, respectively. The benefits of carbon transistors will be more noticeable on three-dimensional integrated circuits, and their theoretical power consumption performance will be 1,000 times greater than that of silicon-based processors. Is this method thus unreliable? Can China outcompete the semiconductor industry by relying on carbon chips? Can the limitations imposed by lithography equipment be totally eliminated, even in China? According to US statistics at the moment, this similar development is actually feasible. Nanocarbon materials can be processed at lower temperatures, with higher working performance and less energy consumption, making the production process simpler. This can also solve the technical issues with 3D integrated circuits. The difference in power usage between 3D integrated circuits based on silicon and those employing nanocarbon materials is theoretically 1,000 times greater. The creation of carbon chips is now viewed with more optimism. It is not difficult for China to surpass carbon chips with diligent study. Only the creation of more compact nanoscale lithography equipment has China been unable to move forward with chip development. More technical assistance is needed for the development of lithography equipment, although the Netherlands, which has the best capabilities right now, has been utilized by the US. Because of this, it is doubtful that China would desire to see more technical improvement in this field, but if carbon chips can really be produced, it would eliminate the need for China to create lithography technology. China stands to gain much from this type of growth. Since lithography machines do not need to be developed, it is stronger to develop carbon chips as a whole. As a result, the overall output of carbon chips and their functionalities are superior to those of earlier chips. It can now be utilized in more industries and has a greater performance after being improved. Although the technology embargo put in place by the United States against China has certain effects, China is unfazed and has been aggressively seeking remedies. China has achieved a lot in this search process. China has also boosted its lithography machine production from 90 to 28 nanometers. Even if it is alleged that it has not yet attained the highest standard in the world, it has advanced. Now, if carbon chip production is successful, China will be able to outperform other countries in the chip industry. After all, this is a completely new one that hasn't been tested with other nations. If China is indeed able to advance in this field, China will no longer need to strain its brains to create lithography equipment. Carbon transistors are tiny cylinders of carbon atoms that are 100 times smaller than existing silicon transistors, meaning that carbon transistors may be made even smaller by employing carbon nanotubes as the channel conducting material. Combining the aforementioned benefits, scientists have predicted that carbon-based circuits manufactured using a 28 nanometers technology will function on par with silicon-based chips manufactured using a 7 nanometers method. Carbon-based circuits outperform silicon-based chips in terms of power consumption and energy efficiency ratio in lab settings by a factor of 5 and 50, respectively. The benefits of carbon transistors will be more noticeable on three-dimensional integrated circuits, and their theoretical power consumption performance will be 1,000 times greater than that of silicon-based processors. In other words, China needs to alter its approach if it wants to exceed the chip. The carbon-based chip and photonic chip are both novel techniques. Since we are now unsure of which approach will be effective, it is imperative that we keep up with others. Important. China has an edge in the production of carbon chips, and carbon-based circuits need 50 times less energy than conventional chips do today to function. It might be more potent whether it is already applied or still being used. The infusion of China's total economy will get stronger with this sort of chip. Thanks for having your watching in this video. You can add your ideas or suggestions below. Please keep following our channel and like our videos.